It's secure digital life.
This is a Security Weekly production.
Welcome to Secure Digital Life. And you type in AAA porn or whatever it is you're typing in. I'm sorry. I was at a PG show.
And I'm really excited to be here.
I'm glad you're here because somebody needs to know what's going on.
That's right.
Okay, so
now somebody has to drink this.
I think it's another day. It's another episode.
Yeah, he's looking at the wrong camera.
Oh, you put my camera over here. Cut. Basically, forget you ever saw that. I think actually forgetting you ever saw that would really be a good idea at this point.
Thank you, Doug. You are off on your trip and whatnot. I am glad you guys got to go have a good time, and some of us had to stay here and do real work and, you know, pay the bills and pay for that trip that you're on because, yeah, okay, somebody has to do that. But I'm here, and I'm actually don't have a fancy set today. I don't have a fancy crew, except that they're going to have to tweak this up after the fact and make it look better than I'm sure it's going to look when I did it. I don't have anything like that. It's just me and my lower quality lights and my halo effect, which I see there on the screen. So it's like, but that kind of thing. Yeah. So it's just that. Usually when I record videos on this studio, it's audio only with slides. But no, you get to look at me. I know you wanted to. I know you were going to be sad if you didn't get to. Today, Doug and Russ are off on a trip to Tel Aviv. And they're going there to meet with some security companies and University of Tel Aviv and some stuff like that. So the show for next week will actually be from, they're going to film a show in Tel Aviv or somewhere. I don't know where. They'll have to let us know. But they're going to film a show in Israel and send it back. So they'll actually be on a plane while the show's airing next Tuesday. But there's going to be a show. Russ is going to talk about, and Doug are both going to talk about resumes and how to put your resume together for tech jobs. So you'll be sure to want to check that out. Today, I'm going to start our conversation about Linux. And I wanted to talk about Linux because one of the things that comes up over and over again on job listings, interviews, on everything that you do is Linux. One thing that our employers constantly asking for is, why don't people know more Linux? Why don't people have more exposure to Linux? Why don't people do Linux? Why don't people love Linux as much as we all do? And on and on and on. And so I decided we should at least have a conversation about Linux as we go along. And we want to do some, kind of like we've been doing other things and sort of build on it. And I know next week we're not going to do demos because we're going to be in Israel. And it's a little more challenging there, but the week after that, hopefully we can come back and start showing you some different things about Linux and how to get started on that. Today I just want to talk about what Linux is, how it works, and how you can get started doing it yourself. And because it's very easy, and unlike many things, it doesn't cost very much to get involved in, and it doesn't even take much in the way of hardware. So many things that you can do with Linux are actually really, really cool. So this episode was entitled What the Fork? What is Linux anyway? And the reason I called it that was, you know, obviously it's a play on words in case you didn't figure that part out yet, but I figure you probably did. A fork is a term that's used very, very often in software development, especially in open source software development, which it refers to someone who has taken something that was already there, modified it to some extent, and now released it as a new version, which is called a fork. And I guess that came from a fork in the road, you know, I don't know, Green Day, old expression, idioms, I don't know, who cares. But basically, I was going to talk a little bit about where this came from and what's involved in getting started with it currently. Well, in the beginning, there was Bell Labs. And Bell Labs, which was a division of AT&T, or I don't know if they got bought or whatever, but originally Bell Telephone, which I guess was started by Alexander Graham Bell. I don't know. I mean, you know, Watson, come here, I need you, or whatever it was he said on the first phone call repeated. He probably said, what the, you know, but yeah, he didn't really say that. I don't know. That's the legend anyway. Bell Labs was working on trying to develop operating systems. And back in the days of mainframes, so this is back in the 70s, and even further back than into the 60s and 50s, but by the 70s you started to see mainframe computers and mainframe technology that was kind of capable of being very sophisticated. And companies started writing operating systems for these pieces of software such that, or these pieces of hardware to manage the low-level pieces of that hardware. And that, and this has been around a long time, so, and I'm not a historian on it, so if you are, I'm sorry if I don't get every last detail correct, but that's not the point. But basically what happened was most of these mainframe systems that were being sold had proprietary operating systems that had been written by some engineering team somewhere or other. And Bell Labs developed a new one called Unix, and there's a whole sort of history of that if you want to read about it on the Wikipedia or whatever, relating to how the name Unix came about, and it's pronounced like E-U-N-U-C-H-S, like Unix, like, you know, the people have been castrated, but that's not what it was. Although there was like multiple plays on words. It actually came from a system called Multics or something like that. And Multics was a really old mainframe system, and Unix was like an emasculated version of Multics, so it's like 2 or 3 plays. Yeah, this is computer science, people, for you. But basically, that got written in C and assembler back in the maybe early 70s, and it was a thing called Unix, and it was originally spelled U-N-I-C-S, and then they changed it to U-N-I-X for some reason, and I don't know all the history of that. But basically what this type of operating system consisted of was something called a kernel, which most operating systems today have. And a kernel is basically this low-level set of instructions that manages all of the hardware and potential hardware for the system that's actually built into it. So there may be added on hardware, and this is, again, mainframes were doing this stuff back in the 60s, where you could bolt on all these different pieces of hardware to the mainframe, and that was add-on. So now new code gets added. So the kernel ends up being this sort of central thing that's often called the master control program. And if you've ever seen the old movie or the old game Tron, not the new one, but the old one, there's a whole sequence in the movie Tron where the what's his name, Bruce Boxleitner, is taking on the master control program, which is this is called the MCP. And the kernel basically does that, and so utility things can be bolted onto the MCP or the kernel to control other peripherals. So if you plug something into the system later that wasn't standard, those things become little utilities and little drivers and things that get added to the kernel itself. But the kernel itself is kind of sacrosanct, and it becomes the sort of core piece of the operating system. And most of what we talk about today, and again, if you're an operating systems expert, please, you know, I'm kind of just taking this down a notch, so don't get all upset. This really isn't a show for you. This is more for people who don't know what all this stuff is. But basically, that gels down to being this central piece of the system. So today, in the world, when you hear somebody say Microsoft Windows, when someone says Mac OS or Android or whatever, they're primarily talking about the kernel. So that's the core personality of that system. Now, we can plug lots and lots of things into these operating system kernels, but that core piece couldn't really be changed. And today we have proprietary kernels like Windows, Mac OS, that you can't manipulate, and we have open source kernels which can be manipulated. And some of those we're going to talk about, particularly these open source ones. So Unix got started, and initially there was 2 big, and again, if you're a historian on this, I'm not giving you all the grim details. It's not a play-by-play, it's just sort of some highlights. But 2 of the big operating systems that came out of that initially were BSD and System 5. And those were fairly well-known operating system. Berkeley Linux and System 5 were out there. And those evolved into a whole pile of things that, if you think about it, you'll read about today, or you can see in the show notes. Like HPUX was what Hewlett-Packard developed, and HPUX was a very, very popular variant of Unix. Solaris, which became the Sun sort of flagship operating system, again was a derivative of. These are all forks of the original Unix. AIX, which was another HP derivative that I used to work with a lot, and Xenix, which was something that was developed by Microsoft. And all these were designed primarily for servers. So there was not a huge marketplace for these sort of difficult to use, unuser-friendly systems going out of the, say, 1980s. Now, back in the 80s, the end-user market was DOS and things like that. And these operating systems were just too big. Typically, this was a weird little thing where this graph, the line on this graph crossed at some point in the late 1980s. And we went from these are too big to run on personal hardware to wow, our mainframe's not quite as big as what's sitting on his desk. Or now today, of course, my Apple Watch is more powerful than yeah, I don't actually have an Apple Watch, so if somebody wants to send me one for Xmas or whatever, feel free. But basically, there was a crossing of that graph, and suddenly all these Unix systems that have been running on mainframe, big iron, it wouldn't fit on these personal computers, were now actually smaller than some of the stuff people were trying to do because they were adding graphics to it, they were adding all these drivers to it. So these proprietary things got developed then and were very well known. There was a lot of training and jobs. You used to see tons of jobs at AIX, Solaris, HPUX, whatever on there. And if you knew those things, you could get a job. And there were others as well that were also proprietary. Like MVS is one of the most famous ones. Was the IBM flagship mainframe operating system. And one of the classes that everybody took in computer science, if you're a computer science major back in the day, and probably still today, was operating systems. And it was a course everybody kind of dreaded because one of the assignments in that course was always to develop your own operating system. And obviously, that's not a small task, and especially back in the 1980s, it was a fairly arduous task because there wasn't a lot of groundwork, and you were writing in a shell or whatever. But the idea of open standards had come about, and open standards meant not usually what people think it means, but open source and open standards, new, all that kind of stuff, GNU if you don't know, new standards and all those things had come about, and this was groups of people who believed that source code should be available so that people could fork it. And that through that kind of, decentralized model of development, we would get really good things, which proved to be quite true. And today we still see that, whether it's in indie games or it's in indie source code or whatever it is. But open standards don't necessarily mean that it's free. It doesn't necessarily mean that you can just do whatever you want with it. But way back in 1983, the new standard, and this is GNU, like the animal, and GNU basically started a project back in '83, which was to create a free Unix-like system, and they had zero success. I mean, this was a difficult idea for people in 1983 because the idea of owning an operating system or spending a lot of time on an operating system and then giving it away was fairly malevolent because you were seeing people make a lot of money off of operating system development, like Bill Gates and people like that. And again, we don't have to get in a whole argument about Bill Gates and DOS and where DOS really came from, and did Bill Gates really summon demons and have them convert that into source code or whatever it was that he supposedly did. I don't know, but the new project had very little success with this and not much came of it. But in 1991, a guy named Linus Torvalds was a graduate student, and he actually produced a new kernel that he decided to call Linux. And so he took the open standard of Unix that had existed for a long, long time, and he redesigned it. He built his own kernel. I won't swear it was a grad school project, but I think it might have been. But he put this under new open source licensing, which essentially meant that in this case it was actually free. Now, you have to read the license to know for sure, but this kernel included a lot of things that were new licensed, which is things like GCC, which is a C++ and C compiler, that all of a sudden, this was just anathema to these big companies like IBM and HP and so forth, because they had been licensing compilers for years and years and years, and this cost a lot of money. So you had to rent a compiler from IBM every month. You paid a fee on it. And all of a sudden, here's this new project that's releasing compilers for free. And here this kid comes along who writes an open source operating system kernel, releases that for free. So all of a sudden, instead of paying IBM for a server license for something, or paying Sun to license Solaris and a C compiler, you could actually run on your server this much smaller, much more efficient, much more effective version of Unix that is now called Linux. And that was how Linus Torvalds kind of got in the game, and that's where the name Linux sort of came from. Now today, almost all these things still persist. So whether it's you're looking for something like BSD, BSD still exists in the form of actual BSD, which is Berkeley Unix, which is the University of California, Berkeley. They also have variants called NetBSD and FreeBSD. So if you want that hardcore, pure experience of the old, and it's very powerful, so don't make no mistake, I'm not criticizing it. FreeBSD is an awesome product, and it's used on a lot of servers. So people that are developing things often use these products. But I'm gonna keep saying this over and over again through this whole little spiel. Please read the license for the stuff that you're using, because I'm going to tell you what happened, and this is a little bit of a legal warning to you. Nothing matters until it does, and by that I mean nothing matters until there's money involved. No lawyer will ever care that you exist, live, or die until there's money to be had. Sorry, lawyers, but I know I'm kind of making you out to be the scavengers of the world, but whatever. When you develop something and you write, let's just say you write an indie game, and you say, I'm going to put this little fun indie game together that is something really strange. And you say, okay, what fun it is. Nine Mins Morris. So you write a Nine Mins Morris app. If you don't know what Nine Mins Morris is, that's why Google exists. But Nine Mins Morris app, and I used to give that assignment in my programming classes. And Nine Mins Morris is an ancient game. It's pretty much, I guess, open source in that context, because it's been around since the Middle Ages and it's very, very old. Okay, fine. You take that, you write an app for iPhone, and all of a sudden that app becomes one of the most popular apps in the world. It's bigger than Angry Birds was. It's bigger than, I don't know, pick something. And all of a sudden the app is worth $50 million. That's when the lawyers wake up and they come and they say, wow, you violated a licensing agreement right here at this point, and because of that, the university owns the game. The university won't care either until they do. And they won't care until the money comes in. And all of a sudden, you're going to get a call from University Legal or from your company or whatever. I've seen this a bunch of times. I've seen people who develop things, and all of a sudden, they made it was worth a bunch of money. And the companies, I did a couple of cases with it, where a lawyer is now saying, look, you used company equipment and company time to develop this app. And because of that, we actually own it. I used to work for a secret government lab, and they had if you read your contract carefully, if I invented an app while I worked at a secret government lab, I invented a piece of software, I invented Linux, they own it. So if you're playing with this stuff, be sure you read your licensing agreements and be sure that you are not using someone else's equipment, because that all becomes under what's called intellectual property law, and it's really complicated, and it's really going to suck a lot when you think, hey Ma, look at me, I made it big. I'm worth $50 million because they're going to buy my app. And then you find out, no, they're not going to buy your app. The company's going to buy your app, or some other license that you violated is going to buy your app. So be very, very careful how you do that. Today, there's all kinds of Linux things that exist. And basically, these are called distros, or distributions, whatever you want to call it. If you want to sound cool, you can say distros, man. If not, you can just say they're distributions of Linux. Yes, that's what we're dealing with here. Or you can say, well, man, like distros. There is a massive graphic on the internet you can get. I put a link to it in the show notes if you want to go look at it, that shows you like the entire genetic tree of all the different types of Linux that are out there. Remember, because this is mostly open source stuff, it's forkable. And because it's forkable, you can actually go grab one of these distros, read the licensing very carefully, and fork your own instance of something and create a new distro that is yours. So you can make one called Bob if you want to. Hi, Bob. So I want to go through them real quickly and just talk a little bit about the different ones so that because you'll get confused when you get in this. So Linux, the original Linux that Linus Torvalds developed was initially called Red Hat. And Red Hat was initially free, but later became a commercial proprietary operating system. So if you want to use Red Hat today for your business, you have to pay for it. It's not free. It's open source. You can see the source code, but it is not a free product. I don't know what Linus Torvalds' involvement is. I have no idea, but basically, at this point in the world, Red Hat is not free. But if you want to use Red Hat and Red Hat variants, Fedora, which is a fork, or I guess it's a sub-fork of Red Hat, is available for free. So the difference in Red Hat and Fedora is that Red Hat has support and, you know, all this legalese and all this legal stuff with it, and Fedora is kind of like, here, use this, but we're out. You know, it's on you. So whatever you do with it, you do with it. Again, and I'm not a lawyer, and I've not read the licensing agreement for Fedora. So if you don't take it from me, the other sort of fork that's in there that's heavily used in the world is CentOS. And CentOS, CENTOS, I put all these in the show notes too. CentOS is a very widely used server-side product by people who like Red Hat. And these two trees are slightly different. So there's subtle differences in them, but they're also similar. But you won't immediately jump right in and feel comfortable. It's kind of like going from New Jersey to Alabama. You kind of speak the same language, but there's a lot of differences. And yeah, but unlike that, you probably won't, well, we won't get into that. I'm going to be nice, so I won't start. But that's sort of the red, I mean, and again, the Red Hat tree is a very large tree with lots of roots. And there are many, many, many variants and forks of all that stuff down through there. Probably, and again, this is completely spurious and based on my opinion, which is worth absolutely nothing, but is the most popular sort of fork tree, I don't know, lineage that exists today, at least seemingly, is Debian. And Debian is a huge, huge distro, and they used to really control the market because of this thing called Sarge, which was a type of Debian that ran on all these different platforms, and it was very manageable, very, you know, you could recompile the kernel, and you can do all that with Red Hat too. So I'm not advocating any of these. I'm just telling you about them. But Debian was very popular, but it was kind of hard to use, and it never really got a lot of deep market penetration until a new fork of it came out called Ubuntu. And Ubuntu Linux became, and I know I'm neglecting all these other variations of Linux, so please, I'm sorry, and please, Gentoo people, don't come after me with ball bats, because I know you're out there, and I know that, you know, Kubuntu and all these things. But Ubuntu was one of these things that came out that it was a live CD, and a lot of these others have the same thing. And it came bundled with some graphical user interfaces and things like that, a server version, a user version, and pretty much all these are like that. But for whatever reason, and I've not really studied why, it just sort of took over. And I used to use a version of Linux called SUSE in my classes, and it was made in Germany, and originally all the SUSE documentation was in German, and it was kind of hard to deal with, but then it was really easy to set up, which was what I was looking for. But then Ubuntu came out, and Ubuntu was very easy, but it's from the Debian tree, so it's a little bit different than the Red Hat tree. So there's some things that are not quite the same. Like, for instance, Debian tree stuff uses a command called apt-get to install new software, whereas Red Hat uses a product called yum. And, you know, so there's just these little subtle, you know, you go, hey, I typed apt-get update and it didn't work. And it's like, oh, you must be using Red Hat. You need to type yum. And that kind of thing. So those two big ones. And then the other big sort of tree that's out there is a tree called Slackware. And Slackware, the two distros out of that I've used were Tiny Linux, which is really, really handy for doing like demos and things on, and SUSE Linux, which I had used early. We quit using that because I don't even know if that still exists, or if it, you know, it changed into something else or got bought or whatever, but we used to use that in the lab. And then one last one about this, Android. So Android is yet another fork of all these original things. And all that basically means that, out there in the world, there is a lot of different types of Linux that you could play around with. So things about Linux that then actually come up. One, it was a lot smaller than Windows or OS2 or any of these things that existed back in the 80s and early 90s. And that meant that it was usable. Now, I'll be honest with you, in the early 90s and stuff, trying to run this stuff on PCs was almost impossible. I remember spending days trying to get Gentoo Linux to run on a PC. And, there were no drivers, and you had to write your own drivers, and there was a lot of assumptions about this stuff that maybe you'll just sit down and do this yourself, which was fun to do, but it also took a lot of time, and it limited how much use it got. Other things about this to mention that are sort of unique to Linux that came out of the Unix world is something called root. R-O-O-T, root is the main user. It's a meta user, so root giveth and root taketh away. Pax vobiscum. And root is if you have root privilege, you can do anything. So that means root can deny root self the ability to change root, but can also grant that privilege back. Yeah. Think about that for a little while. We all just read like grains of sand rotating around like, some giant's fingertip out in another bunch. Yeah, that kind of stuff. Exactly. So you can get into some weird things, but the truth about root is all powerful, and root can do anything, and root can take away root's privileges, but root can also give them back. So it starts to sound kind of, I don't know, what is deific a word? Yeah, something, whatever. Linux has repositories of open source software, and these are online storage places where you can go and download updates, you can download new tools, you can download things that are actually embedded in the kernel, you can download things that are embedded in the operating system, and on and on and on. So this is a really modern, it was very early, so long before Windows was doing update and all this kind of stuff, you were able to do these things and update core systems as well as software on these Linux systems by using the internet, which at the time was not very good, but you could do it. Typically back then what everybody was doing was using CDs and things. A lot of these would run on live CDs or flash drives, which was pretty cool. They often were command line interface, and they are based on command line interface. So even when you have graphics, so you see a Linux system like Mac OS is derivative of that, Android, all these things. Underneath all that, there is a command line system which you can actually use, and the graphics interface is really just issuing commands to the command line. So it's really just a scripted screen. Unlike true graphical operating systems like Windows and things, which don't really, the command line is emulated on those. This was often on a server, not a desktop, but today that has changed, and people do run Linux on desktops and laptops all the time. It's small, it's fast. There are limitations to that, obviously, because software that you want to use may not run on Linux. And I know hardcore people are going, Doug, no, you can. And yes, you can, but you're going to suffer for it. The ability to modify the kernel is something that's almost unique to Unix-type trees. By able to go in and recompile the kernel of that system is a pretty interesting thing to be able to do. The ability to fork is certainly an interesting idea, that you can take the kernel itself, modify it, and release your own version or variant of it. Read your license carefully, because you may not be supposed to be doing that, and again, it won't matter until it does. If you do it in your basement and you play with it on your computer, that's cool. If all your friends start using it and suddenly it's a big thing worth a lot of money, that's when they come looking for you. So before you do anything like that, I mean, if you're just playing, fine, but sometimes playing turns into money, right? You've always heard, HP started in a garage. So don't be that guy with that terrible story about how you invented the next big thing and then it was taken away from you by Bill Gates, and you ended up with nothing, and you ended up coding on street corners for spare change. So be careful before you start doing forks, even for fun, because get stuff that's true open source that will allow you to do that, not stuff that's going to say this is fine as long as you don't sell it commercially, which is a common one. And you say, well, I developed it. It didn't say I couldn't develop it. Yeah, you can develop it. You just can't sell it commercially. If you do, they own it. And it's like, whoa, so be careful. It may be free. So it's often free to use for students. It's free to use for fun. But if you start using it in your business, there may be licensing fees associated with it. So be very careful about that, because you can get in all kinds of trouble. It's not necessarily free. It is the most common server variant. So if you go to a server room, the most common thing you see running is some version of Linux. People want you to know command line interface because Cisco, because that's just, you know, PowerShell, because whatever. And of course, obviously, Android is certainly based in it. How do you get started? I know I'm running long, but how do you get started with this? I love to talk about all this stuff, but find an easy distro like Ubuntu and put it on a VirtualBox. This is what I usually tell people to do. VirtualBox is available for free. You can download that. And then you can run Ubuntu inside of VirtualBox if you don't have a spare piece of hardware, but you know, grab an old laptop. This stuff will run on really small platforms. So take your old laptop, you know, that you used to use, and you know, you bought that new fancy Predator laptop for gaming. Take that one you had last year and put Linux on it, and it will give you an opportunity to learn how to operate it. And like most things, the more problems you have with it, the more you'll learn. So if you really have to struggle with it and get it to work, and you probably won't, that's one of the sort of sad things, is that used to Ubuntu was one of those things where it was really hard to get running. Today it's pretty straightforward and easy. But it'll definitely let you have the opportunity to experience it. Try doing it the command line. You know, set it up like the server version of it, which doesn't come with all the graphic stuff, and then you'll have to do that. Set up a virtual web or a web server on VirtualBox and play with it. Get it running. This is a great way to learn Linux and Apache, which is the web server that comes with Linux. Could you build out a firewall? These are just some projects you could try that are very basic, and you can find tons of information on the internet. Could you build out a firewall on Linux? We used to build them all the time. We built out firewalls that literally took a box that had 2 network cards in it, and it was processing firewalling through Linux. Could you build out a proxy server? Proxy server is a really cool thing that can limit people's access to certain websites. We were building this thing called Dan's Guardian, which is an actual product that was actually a proxy server out on CentOS, and we were selling those to schools and businesses and things like that. So that's a thought. You might get into that business. It's very popular. Read the license. And you can emulate all these different distros in VirtualBox. You can even put, you know, a whole bunch of distros in there and play with them because they're so small. So most of these are tiny. They mostly would fit on a DVD at top, so they're like 4 gigs. You can download a whole bunch of distros. Some of them are teeny, like Tiny Linux. And I think there's even one called Really Tiny Linux or something like that too. There's all sorts of them that you can play with. Lots of fun. All this is going to translate into work for you. If you want to learn how to use Linux, let me give you some suggestions. You can take a course at the community college. You can take a course at Roger Williams University if you want to. We have 2 courses in Linux. Cybrary. Make no mistake, Cybrary, a great resource for this stuff that's free, costs you nothing. Udemy has courses in Linux. IT Pro TV costs very little, and if you'll go watch Pulse Security Weekly, they have a discount code for IT Pro TV, so you can jump on board that. And I really encourage. Those guys are really, really good, and they're a lot funnier than I am. So great content there, and of course many, many, many more. And you can always just grab it off of, you know, looking at bulletin boards and whatnot. So while Doug and Russ are busy flying to Tel Aviv via Warsaw, if you can imagine. Who booked that? I was here to provide you with this. Next week on Tuesday, Doug and Russ will be flying back from Tel Aviv via Warsaw to JFK. So we'll have another show that we're going to record in Israel while we're there. And you can check that out. We're going to talk about resumes and stuff that you need to do to actually get your resume ready so that you can get these nice high-paying jobs once you learn all this cool stuff. Thanks for watching. I enjoyed being here with you, even though my studio is not so great. Sorry it looks the way I'm going to fix it. I just haven't done it yet. I know. Thanks for watching, and we'll see you next time on Secure Digital Life. Bye.